Alright you guys, welcome back to the channel. It is me, Sid Singh. We're going to look at stacks in Java for our next part of coding, and we're actually going to look at some stack methods because we're looking at more data structure. So let's go and take a look at stacks, which you can think of like a stack of books, stack of plates, whatever. And basically the order for stacks is you have your stack, right? You add something to your stack, so you get this element. Whenever you add something, then it comes to the top. Everything is moved up and up and up to the head. Obviously, your array is going to look like this, right, from left to right. In this case, the top or the head is going to be whatever is to the right. So let's take a look at stacks and how they work. All right, shall we decrease the zoom? All right, so a stack is a group of items, all of the same type, so they all have the same data type, and items are added to the top of the stack and removed from the top of the stack. For queues, which we might look at later, basically follow the same thing where they're added to the top of the stack, but they're actually removed from the bottom of the stack. Think like a queue. A queue is basically like a line. Whenever we say the word queue, it's a queue of people. There's a line of people, and then we're always referring to the back, right? So we'll take a look at that. The order is LIFO, last in, first out. If you don't understand it, that's fine. I still don't think I understand it to this date, but I do understand how stacks work. So for example, this is a stack. The type is integer. In the first line, we're specifying the data type, which is one way you can do that. You can say stack integer stack. So that means we have a stack. The type, data type of the stack is an integer. I think that's called using generics to specify the data type. And then, so that's one easy, cool way of doing that with the greater than less than symbols, the arrows, and then the name of the stack is stack. Then you have the semicolon, and then on the second line we have stack equals new stack. Data type is non-specified, so it's not really using the generics part there. And when it says stacks will only store integer values, it doesn't mean stacks can only store ints. They can store any data type you want. It's just in this case, our stack will only have integers. And you can see over there you have like a stack of books. So that's kind of how it works. So if you have a stack and you just say stack.push 15, this basically means you pushed 15 onto your stack. So now you have 15 there as an element. Alright, so this is showing the vertical side of the stack. Obviously it doesn't really work like this, but this is just to kind of visualize it in your head. Then I push 47. So the push method is how you add stuff into a stack. So whenever you say your stack name dot push, that's how you're adding the elements to your stack, right? So first you added 15, now you added 47. So push is how you add your elements into a stack. All right. I believe queues use like dot offer or something. They have weird names. And then for removing stuff from a stack, I think you probably use the pop method. Pop. All right. So okay, one more element, 11, and now we're starting to pop. Whenever you pop, you always pop from the head. Whereas in queues you pop from the tail or remove from the tail. For stacks, you start popping from the head. So your head is whatever's at the top. At the top I have the 11, so I pop off the 11. So the 11 is gone. So now I only have 47 and 15 left. I pop off the 47, and I only have 15 left. So yeah, stack methods. And you might implement some of these. So there's push, add, pop, peak size, and search object O. Whenever you normally search, you might think you start with the 0 indexing for the positions, but for stacks, we actually start with the number 1. So just remember that, and I'll show you what it looks like. So we have a stack here. We've pushed in 83, 23, 11, and it prints it out. Notice how everything is just printed out like normal. We have 88, 23, 11 from left to right. Whenever you start pushing stuff onto your stack, notice like right here, right? So the 88 gets pushed first. So when I use this line of code, right, I do this s.push 88. So that's why I have the 88 here, this 88 here. Then I push in the 23, then the 23 comes, then the 11 comes, and then I print it out. So then I get 88, 23, 11, right, in that order. Okay, so whatever order you are writing your code in is the order to be printed out in, with 88 on the left. It's the same for queues. The order will be the same. All right, so whatever you pushed in last will be towards the rightmost element. All right, So just remember that. It's not like it's going to be 11. It's not like whenever you do 88, then you do 23, then the 23 goes to the left. No, it's 88, followed by 23, followed by 11, right? But 11 is your head. So whenever you do like pop or peak or anything, it'll start referring to the elements from 11. 11 is basically like your most important element right now. Whatever elements to the right most for a stack is basically your most important element at that period of time. All right, so let's say for example, you have this, okay, and you call the pop method. So, well, it popped off the 11, right? So you had 88, 23, 11. The 11 is now gone. So now you just have 88 and 23 left over when you print out the stack S. We pop it again. Now we only have 88 left. All right. That's the only element remaining. So here's our same stack, and this is using the peak method. The peak method just returns your rightmost element, your head, whatever's at the top. It doesn't remove anything, it just returns it. So when we print out S, we didn't lose any elements. Whereas the pop method would remove it, the peak method just returns it. So if you were to return your stack again, all the elements would still be there and it would print it out like normal. Alright, in this case, we are making a stack, and whenever we're adding, when we're doing s.add_i, we're going from 0 to all the numbers less than 10, and we're doing integers, so it'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, your 9 is the most important one. So okay, so let's get started. So for the first one, we're going to do s.search 11. 11 is not in our stack, so it returns -1. Alright, it doesn't matter if the element's 12, -10, -2, whatever, any element that's not in your stack, when trying to do the s.search, will return a -1. When we try to do s.search 9, 9's our head, right? And it's at the top of our stack in this case. And it has the position indexing of 1. Not 0, it's 1. That's why when you do s.search, you get, for 9, you get 1. And then every element to the left of it, following the head, gets 1 more. So the 8's a 2, the 7's a 3, the 6 is a 4, the 5 is a 5, the 4 is the 6, 3 is 7, 2 is 8, 1 is 9, and 0 is 10. That's why when you do s.search 0, you get 10. Alright, so now let's take a look at testing expressions with a stack. So whenever you're doing an expression tester, you have to have an open and then a close. And the open and the close have to be the same symbol basically, okay? It has to be matched up perfectly. Like in the first one, if you do a parenthesis on the outside, and then parenthesis on the inside, the opening and the closing have to be the same. For a second one, that's not going to work, right? Because you either need the left one to be a curly brace or this inner right one to be a parentheses. All right, you can't do that. So this will work because you have this pushed onto the stack, then you have you have a opening curly brace, then an opening parentheses, then closing parentheses, then closing curly brace. So it works out nicely. Alright, so this expression is valid. If they're just asking you, is it a valid expression, you'll be able to tell. Alright, now let's take a look at solving postfix with a stack. So postfix operations can work as well. So here's an example where you have 3 and 6, right? This basically means you have 3 and then 6. Well, let's take a look at an example. This example is pretty nice. So we have 1, right? 1 gets pushed onto our stack. So we have 1, then we push 6 into our stack. So now we have 6. Alright, 6 has now been pushed onto our stack. Alright. Now, when we get to the plus symbol, it will add the 1 and the 6. So now it will become a 7. Alright, and all the elements before it were popped off. Now we just have a 7. So whenever you do a postfix for the stacks, you will only end up with 1 element in your stack. Right? Because all the elements will eventually be cancelled out by whatever operations are in between. So now we have 7. When we keep going, we keep adding. We're going to add the 7 and the 4. We keep on adding until we reach an operation. So we had the 7, then we added the 7, then we added the 4. So now 4 is at the top. It's our head. Alright, and now there's a minus symbol, so we're going to stop now. And then, okay. So we had 7, 7, and then 4. Okay, so now we're going to do 7 minus 4, which will give us 3. Alright, think about it. Imagine if the minus sign was right before it. So imagine this plus symbol here is in between the 1 and the 6. It became a 7. Now the minus symbol is in between 7 and the 4. It'll become a 3. It won't do 4 minus 7, okay? Which may think, oh, the head minus the one below. No, it's going to do 7 minus 4, which will be a 3. Now you have 3 and 7. And then the multiplication symbol, right? It will, like I said, it's not 4 minus 7, it's 7 minus 4. So it became a 3, right? That's the bottom followed by the top. But you could do 7, 3, or 3 into 7, either way. 7 times 3 is 21. So that's what we get. And that's it. This is basically how the stack in Java works. But I feel like y'all aren't satisfied with just this information. So let's go ahead and take a look at these stack methods into more detail. Let's pull up IntelliJ and let's see. So let's say, so I have IntelliJ opened up right here. So I will take us to there. IntelliJ. Alright. So let's say, so I have this. I'll make a new Java class. Let me change the viewing icon so we can do this. Okay. So file, new Java class. We'll call it stack. So we have the stack class. All right. Let me go ahead and zoom in a little bit. Cool. So to use the stack, we obviously have to import the necessary things. So we'll say import import java.lang dot stack. I need to do what's it? That's fine. It's not lang, it's util. Come on, I'll keep forgetting. Okay. Lang is for the other one. Import static java.lang.system.out. There we go. It's already defined, isn't it? It's called stack1. And then we can rename the file. Okay, there we go. Now look our main method. Static main string args. Cool. So now let's go ahead and try to use some of our stack methods. Alright. So what is a stack method that we should try to use? Well, let's see here. Alright, so there's the push method, the add method. Let's go ahead and make our stack. Let's make it of type int. So we'll say stack integer stack, and then we'll say okay, so if I want to do stack.add 5, wait, I need to do the other side, right? Equals new stack. Cool. This shouldn't return anything. Anyway, so now let's say I want to do out.println stack. So this should print out our 5. Right? So that's how that works. The add and the push basically do the same thing, okay? Works exactly the same. So now if I do stack.push 7, then we'll get 5 and 7. 5 comma 7. And actually, let's remove that and let's print it here. There we go. Right there. So add and push do exactly the same thing. Alright. So now let's say if I want to do a pop, we'll do stack.pop. And we'll do stack.pop. Doesn't take a parameter unless I want to print this out. Okay, so it'll pop off the 7, it'll print the 7, and now when I print out our stack, we'll get the 5. Just like so. Alright, I'll put this back here. Alright, so just to get a quick visual, we have 5, we have 7, we pop off the, we have 5 and 7, we pop off the 7, right, it's a stack, so we're starting from the head, alright, so we get 7, and then when we print out our stack again, we just have 5 left over. Pretty cool, right? Alrighty, what other methods are there? Oh, peek, I'll show peek, okay. Let's say if I do stack.push 2 and stack.push, what happened here? Alright. Stack.push 5. Alright. Let's print out our stack really quick just to see what it looks like. So we had the 5, then I added a 2 and a 5, okay? Now if I want to do peek, alright, peek's just going to return whatever's at my head, which is a 5. Okay. Well, I need to print that out. There we go. Okay. Yeah, now it's going to print out 5. Did it not run? There we go. Okay. And then size, just the number of elements that I have. I won't take any parameters. So that should be 3 elements, and then we'll try a search. So let's say I want to search for 2. Alright, so that'll be 2. So if I do stack.search 2, I'll try and find 2, and then we'll do a system dot, or we'll just do that dot print line right there. And that'll be 2. This is 1, the 5 is the 1, and then the 2 is the 2. Alright, cool. Are there any other methods? What else can I do? Stack dot. I think I showed you all the main ones. Okay, we can do stack dot empty. And this takes in, tests to see if the stack is empty, right? So this should return false. So this is just a true and false type of thing. And it's not empty, that's what returns false. Are there any other methods I have not done yet for stack? Might be some more methods. Let me take a quick look, but I think y'all got it now. Stacks are, in my opinion, like a really easy data type to learn. Like you can learn them like a long time ago. Like it doesn't really take that much experience, but that's just a cool data type you can use. Kind of like arrays, you know, just adding, removing stuff in general. Nothing too hard, I'd say. So I'll see if there's anything else I can show y'all with stacks. I know they can be pretty useful to use as a data type. I showed y'all push, peek. I think I showed y'all the main ones. All right. Yeah, and then what else is there? Oh yeah, this one. All right. So for stacks, you got the main gist of it. Yeah. Okay. But I guess what I can do now is, if I were to show y'all anything else, because I think y'all are pretty smart people, so I can figure out most of this stuff. I'm trying to see if I've missed anything yet. Okay, so I guess I'll show you this. If we use a while loop, while not stack dot is empty, so while it's not empty, we can do an out dot print line of stack dot pop. All right, that's gonna be really cool to see. It's gonna print out 525. We start with the 5 from our head. We start popping. 5 popped off, printed. 5 is gone. Now 2's our new head, so it prints out 2 popped off, and then 5 prints out 5 popped off. It's empty. We're done. So we get this 525, and that's basically it, y'all. That is stacks in Java. Showing y'all how to use all the stack methods. So hopefully now y'all understand how the stacks works in Java. Thank you guys for watching, and my next video I'll probably go over how to use queues in Java. Alright.